our next speaker. That's going to be Judy Allton, and she's going to talk about some of the lessons learned from Apollo and lunar sample curation. So Judy, are you online?
I am. Good day, everyone. Next slide, please. During Apollo, we had time to adapt the sampling tools to the lunar conditions that we actually encountered, as Adam has pointed out. Curation was also able to adapt as we learned more about the nature of the lunar materials. Next slide. Sampling strategies to increase diversity. And most people think about that in terms of staying longer or traveling farther on the lunar surface. I wanted to mention the contribution that specialized tools make to diversity, and Jack really took care of most of what I had to say about that. In this bar graph, the blue bars show the number of samples collected on each mission. The black squares the average weight of samples from that mission. So you can see with some experience, we ended up with more samples and slightly smaller samples, so a greater diversity. The sampling tools that were used, many of them evolved throughout the missions, as Adam again mentioned. I will concentrate on a drive tube to show some detail about that. And special devices were added that increased the diversity. Next slide, please. This rake tool has been shown 5 times already this morning, and that's a picture of Jack using it. They had 1 centimeter tines on those rakes, and they collected a total of 665 small rock specimens from Apollo 15 through 17, and each, I think an average weight was somewhere around 70 grams. Jack also mentioned the deep drill, which was a rotary percussive drill. It was introduced on Apollo 15 and flew on the last 3 missions. So that retrieved that soil column of 2 to 3 meter depths, which does enable diversity related to depth. The contact soil sampling device is probably less familiar to people. It flew on Apollo 16 and had what I think is a worthwhile goal to collect ground truth samples useful for remote sensing. The 2 sample pads that you see there were about the size of your cell phone, slightly wider than your cell phone. One was set up to collect a very pristine sample of the upper lunar several hundred microns. The other, a pristine sample of the upper 1 millimeter. And such great care was taken to acquire these samples behind a shielded boulder that not as much material was returned as hoped. I also have a question for Adam I'll follow up on later. He showed a set of tools they were working on, and I think I saw a container like this, so I'd be interested to know what those folks are thinking about with regard to that and how that might be updated for that same purpose. Next slide, please. Okay, how did we adapt to the new knowledge? These are the drive tubes. The tubes you're looking at were roughly 30 centimeters in length. The picture is Buzz Aldrin pounding one into the regolith. And the tube that came back had only 10 centimeters in it. The lunar regolith was much more dense than had been planned for and designed for, and that was part of that problem. But between the end of July and November in 1969, the bit on that Apollo 11 style drive tube was redesigned and flown on Apollo 12. So 12 and 14 also were able to collect entire tubes full of soil. The drive tubes were redesigned more completely for the last 3 missions. The diameter was increased to 4 centimeters with a thin wall. 2 tubes could be screwed together, and those would penetrate the regolith and help retrieve 60 to 70 centimeters of soil with minimal disturbance of the fine layering in stratigraphy. Next slide, please. I will switch to curation issues now. When you have these samples, there's some technical tensions on how to care for them. In the early days of Apollo, when we were still trying to contain samples and preserve the sample pristinity, the competing technologies were negative versus positive pressure glove boxes. So let me go on to the next slide, please. Another technical issue had to do with balancing keeping things clean from a molecular organic point, or keeping them clean from particulate contamination. And those two technologies also fight against each other because a lot of the dynamic filtering devices will put organics into your sample. And if you have a glove box with not active particle removal, particles are going to accumulate from handling. Next slide, please. I thought it worthwhile to take a quick look at the vacuum glove box that was set up in the Lunar Receiving Laboratory. This cartoon shows how it was put together. The blue-gray areas are ultra-high vacuum at 10 to the minus 6 torr. The gold areas vacuum transfer locks, and the red one operated at atmospheric pressure was a series of 3 boxes to decontaminate the box before it was inserted. The decision to use a vacuum glove box was fairly straightforward. It mimicked the lunar environment. It was an attempt to preserve the lunar sample pristinity, and it was unknown how lunar material would react with various cover gases. On the downside, it was very complex, making it somewhat less reliable, and any failure in a vacuum system could compromise the samples. Apollo 11 and 12 each had a glove failure that was described as a dynamic implosion. It's a high maintenance type of a system. The original team required 15 people to operate. Next slide, please. These photos are just to show you visually an idea of the complexity. The upper left shows the device built to match that cartoon, and on the lower right is the control panel to operate the vacuum glove box. Next slide. If you worked in there, these are scientists looking at the Apollo 11 samples. And for those of you who have been in the Lunar Pristine Lab, contrast the cluttered and cleanliness look. Next slide, please. So curation capabilities range from the Apollo rocks, fines, and cores, picking up small particles extracted from silicon oil or aerogel, to atoms embedded in crystals. We went from a vacuum glove box, positive and negative pressure glove boxes, laminar flow rooms, and finally a nitrogen glove box in a laminar flow room. Next slide. This is a timeline of how we got there. Next slide. Next, two samples of two images of boxes people have been interested in. This is the Apollo Lunar Sample Return Container and a close-up view of some of the seals. Each box had 3 seals, 1 knife edge into an indium silver alloy and 2 fluorosilicon. Next slide. And a gas tight container. This one was about, that's a 2-inch scale bar in there. There was a larger one, so samples were collected in those. Chip may talk more about this one. And so the last slide. From all this, I guess the main thing I'd like to suggest is the permanently shadowed regions really are new territory.
1 minute.
I think it'd be wise to prepare to be flexible and fast at adapting and redesigning the hardware between the missions. That's all I have.